All right, we're going to be looking at application of radians, rotating, and finding points on the unit circle. So Teresa puts her pencil at point A and traces the unit circle counterclockwise. So let's establish counterclockwise is going opposite of the direction of a standard clock. So it's going in that direction. What is the radian measure from point B? So this is going to be our reference right here. Okay, so there's our reference for each of the radians and degrees for which she traces the circle. All right, so she's going to trace the circle 3 pi over 2 radians. Okay, well, 3 pi over 2 radians, well, let's go ahead. For ease, we can change that to degrees because I think we're a little bit more comfortable with that at this point. So what is 3 times 180 over 2? That is 270 degrees. So she's going to be rotating 270 degrees, okay? Now, her starting point is 5 pi over 4. So where is that necessarily? Well, 5 pi over 4 is 225 degrees. So let's go here. We're at 225 degrees, okay? So from that point, we need to go ahead and rotate 270 degrees, okay? So let's break this down into pieces as we rotate this direction 270 degrees, okay? Well, if we're at 225 and this is 270 degrees, we know that this little angle right here should be about 45 degrees. That arc right there should be 45 degrees, okay? And what we need to do is keep going until we've gone 270 degrees. So we've gone 45 right here. We go another 90, okay? And then we go another 90 degrees. So at this point, we've gone 90 plus 90 plus 45, which is going to bring us to 225 degrees. Well, our goal is to go 270. So how many more do we have to go? Well, let's take 270 and subtract off 225. And if you're having a hard time with that, we can come over to Desmos and type it in, 270 minus 225. We still have 45 more degrees to go. Okay, so let's go another 45 degrees in. So there's our last one. We go another 45 degrees, brings us to approximately there, 45 degrees. We are at this location. This is the end of our rotation. Okay, now the question was, what is the radian measure from point B? So what I'm going to do is I'm going to start from point B. Okay, and what we want to do is find the radian measure all the way to this location. Okay, so let's go ahead and do that. Let's find out how many degrees we've rotated from point B. So from there, we know we have a 90-degree arc, okay, plus a 45-degree arc in order to get there. So that is a total of 135. So from point B, we've traveled 45 plus 90, which is 135 degrees. 135 degrees from point B, because we got to answer this question. Now, 135 degrees from point B, we need to convert that over to radians. And we've got lots of ways to convert back to radians. Could I take 135 degrees and we can go as an approximate method? We can say, well, 135 degrees divided by 57.3 degrees. And remember, that is 1 radian. And we can do that. We can say, okay, well, let's approximate it. Let's take 135 degrees divided by 57.3, and that gives us about 2.356 or 2.36 radians. So we can say, okay, well, that must be 2.36 radians. Okay. We can also say, okay, well, let's go to converting the degree over to a radian. Okay, well, we can go back to that and say, one of the things we learned with our unit circle was that since this is a 45-degree angle, well, guess what? There are multiple 45 degrees. There's a 45, there's a 45, there's a 45, and there's a 45. And remember, out here, we have 180 degrees, which is pi. So how many is that? That is 1, 2, 3 45s out of the 4 45s that fit in pi. So I could say, okay, well, in that case, we can say, well, 135 degrees is the same thing as pi divided by into 4 pieces, and we are using 3 of them. Okay, so 3 pi over 4 radians. So we come back and we say, okay, from 135 degrees from point B, we've already understood that is 2.36 radians. And since that's 2.36 radians, we also found that is 3 pi over 4 radians. So 3 pi over 4 radians. Now, in part B, I'm going to go clear all this out. Okay, part B asks for something a little bit different. Okay, part B asks us to, what are the coordinates of x, y? At what coordinates x, y is Teresa located at after tracing the circle for the degrees and radians above? Okay, so what we did was we located her at 2.36 radians, which was the same as 135 degrees, which was the same as 3 pi over 4 radians. So how do we find the points at which she's located? Because this is where she located herself from the reference B. Simple. We just go to Desmos, and what we're going to do is we're going to say, we could do it either way. We can say, remember, x and y are the same thing as cosine of the degree or the angle, and then cosine of the angle, and then y is the same thing as sine of the angle. So let's go ahead and do it. We can do this in degree or radians. I come back to Desmos. Okay, and I'm just going to type it in. Let's go with cosine of 2.36 and sine of 2.36. Okay, and you'll notice that those answers are right there. Okay, notice they're very close. We are in radian mode right now. So if we go over to graph setting, we go to radians. Okay. And we could also, if we wanted to, type in cosine of 3 pi over 4. Notice it comes out the same, and sine of 3 pi over 4. We could, and notice again, it comes out to be the same. We could also have done this in degree mode, where I post it in degrees and I type in cosine of 135 and sine of 135. I just need to make sure that I am in the right. Mode. Now you'll notice once I change modes, the other answers change as well. So we know that the answer should be negative 0.707 and positive 0.707 in this case. So just write, after using that, just simply write negative 0.707 comma positive 0.707. All right, that is rotations on the unit circle. Hope that helps. And good luck with the rest of the problems.